Hello everyone and welcome to the next lesson on radioactivity. Today we are looking at the history of the atom. First I'm going to put up the quick quiz from last lesson, so pause the video and have a go at the questions on the screen. The answers are on the screen now, so if you got it right give it a tick, and if you got it wrong then correct your answers. Next we're going to do a quick recap on ionizing radiation. So pause the video and complete the table on the screen. This information is really important. We're going to use this throughout the next few lessons. So if you got the answers right, give yourself a tick. If not, then write in the correct answer. That's really important. So everything you didn't get, you fix it and then you'll know it for next time. So this is a quick recap from the alpha particle scattering experiment from last time. It's made up of a few main bits. We've got the radiation source in the bottom left. That fires alpha particles, a bit like bullets, like tiny little particles. And if you make a little hole, then it will come out of a single hole. And they'll go forward. They will aim at a thin sheet of gold foil. And when they go through the gold foil, they will do one of three things. We looked at them going straight through, deflecting, or deflecting backwards. And then they will hit the fluorescent screen on the other side. Every time they hit the screen, there'll be a tiny little flash, which you can then look and see exactly how many particles are hitting your screen. This was the equipment. This was the practical. Very simple. It had to take part in a vacuum, so the whole place was this whole experiment had all of the air sucked out of it. And the reason why that is the alpha particles can't travel very far in air. So you suck the air out and it allows the alpha particles to go without hitting anything. From that experiment, you need to remember three main results and the three conclusions that come from them. So pause the video and see if you can remember the three main results from the alpha scattering experiment and the three conclusions that relate to them. The results are shown on the screen now. So most alpha particles went straight through. Didn't hit anything, just went straight through. Some of them deflected. If you have a look at the diagram, you can see some of them deflecting, bending slightly. Now it's important that they're not hitting the nucleus. They're getting really close, but they're not quite touching the nucleus. And the last one was few deflected backwards. You can see one of the arrows on the diagram is deflecting backwards. So they're the three results. That is what happened. And the three conclusions are this. The first one is that the atom's mostly empty space. If most are going straight through, then that's the conclusion you come to. Most of the atom's empty space. And that's why the current day atoms, there's mostly gap between the shells of the electron and the nucleus. It's just empty space, so the alpha particles can go straight through. If some of them deflected, it means the nucleus is positive and repelled by the positive alpha particles. So the nucleus is positive, the alpha particle is positive, and it repelled, which made them deflect. So interestingly, they didn't actually touch. It's not like they were hitting and bouncing off. They were getting close, repelling, and then moving away. And the last one was the nucleus is very small and very dense. All of the mass is concentrated in that tiny dot in the middle of the atom. That's where all the mass is. So when they come and hit it, they will then go, they'll deflect completely backwards. Now hardly any did that, very, very few. And if you think back to the plum pudding model, you'd expect most of them to do that because it was all solid and dense like a plum pudding. And that's why after the experiment, we went from the plum pudding model and we changed it to the nuclear model. And this is a diagram to show you on the left what they thought atoms looked like, and that was called the plum pudding model. So a solid lump, like a solid cake with bits of fruit dotted inside. They thought that. They thought the charge was the cakey bit was the positive charge, and the fruit dotted inside were the electrons, the negative electrons. But actually, we now know it to be the nuclear model with a nucleus. And it all came from that alpha particle scattering experiment. This video is looking at the history of the atom. So we're firstly going to be looking at what they thought atoms looked like, and then we'll be going through about each stage and how each one changed. So if you get stuck at any point, you can pause the video and go back and watch that section again. You don't need to remember the dates. I put them on there because it's interesting, but you do need to remember the order of this, all of the models. So this is the first one. Originally, they thought the atoms were tiny solid spheres. So they did think there were atoms around. That was thought for a long time before this. Tiny little balls that make up everything. They did think that. But they didn't know what they actually looked like. So they originally thought, because our objects are solid, like a table's solid, they thought they were solid spheres, a bit like a bowling ball, I guess. So we're talking about 1800, and it was suggested by John Dalton. So solid spheres, and they thought that because, you know, you hit something and it feels solid. They had no idea it was made of things. That only came later. Later on, a scientist called J.J. Thomson discovered the electron, and that changed the way they thought of this model. They didn't think tiny solid spheres anymore. They thought their electrons must have been inside the atom, but they knew the atoms were overall neutral. So they had this model called the plum pudding, and they thought it looked like a plum pudding on the right. So there was a solid lump. The cakey bit was the positive charge, and the electrons were dotted around it, like the fruit dotted around a cake or the pudding. So overall it was neutral, and it was solid, and it was just a positive charge with negative electrons dotted around it. Then came the alpha particle scattering experiment. This was done by Ernest Rutherford in 1909, and they thought about the plum pudding model. They thought that's what it looked like, and then they did this experiment, and because of these results and the conclusions they could make, they had to change that model. They had to change what they thought the atom looked like. And this was the experiment that did it. So it was a real turning point in the models, in the atomic model, and it's a really important one. And there's another video on that one if you want to go and search that experiment. After the alpha particle experiment, this is the model that they thought the atom looked like. So it used to be plum pudding, and then after the experiment, everyone thought this. And it's called the nuclear model because it has the nucleus, you can see. And have a look at the diagram. It looks really similar to the one we have today, but not the same. They thought there was a nucleus, and they thought there was electrons around the outside, but they didn't think the electrons were in shells like we do today. And they didn't think that there were protons and neutrons. They didn't know they existed yet. All they did know was there was a nucleus and electrons around the outside. So there were some things we did know and some things we didn't. But all you need to know for now is that it went plum pudding and then nuclear model, and then you can start comparing how similar, or getting closer and closer to today's model. Here is a recap of the three models we've looked at so far. So it started with tiny solid spheres. Then that changed to the plum pudding model once we discovered the electron. And then after the alpha scattering experiment, it changed to the nuclear model. So you can see how it's been changing just from these first three. So they didn't think that protons and neutrons existed yet, but we do think by the end of this, there is a nucleus. What I'm going to do now is cover these up. I'd like you to try and remember. Don't write them down. Just try and remember what the three were from memory. So hopefully you have tiny solid spheres, plum pudding model, and the nuclear model, but no protons and neutrons yet. Now you can pause the video and write down the answers to these questions. The answers will be on the next page. The answers are on the screen now, so you can check your work. If you got it right, give it a tick, and if you got it wrong, you can add in the correct answer. Okay, pens down while we discuss the next one. There'll be time for you to write in a second. In about 1913-ish, a scientist called Niels Bohr had a look at the nuclear model, and he came up with a very slight adjustment to it. So they still thought the nucleus was there, but he arranged the electrons into shells. And each shell was a fixed distance from the nucleus. And this is much, much more similar to the one we have today. So the nuclear model had a nucleus and electrons around the outside, but the Bohr model is the adapted version, and Bohr put the electrons in shells. Next, Rutherford was the same scientist who did the alpha particle scattering experiment, discovered that protons existed. Now, but neutrons hadn't been discovered yet, but protons had. And you might think it's interesting that electrons were first and then protons and then neutrons. But if you think about it, it makes sense because neutrons are not charged, so it's much harder to detect them. So it was electrons first, then protons. And we didn't think neutrons existed yet. All they thought was that the nucleus contained protons. And that was done by a different experiment again. But it was Rutherford who was the scientist who did that. So we went from the Bohr model, and then we discovered that protons were in the nucleus. Lastly, a scientist called James Chadwick did an experiment to show that neutrons existed. And now we've got a model of the atom that contains shells, it's got a nucleus, and that nucleus contains protons and neutrons. So this is the model that we have today. And the very last thing to be discovered was the neutrons. And you do need to know that scientist's name. His name was James Chadwick. Now, obviously, this diagram is so we can see it, but really the scale is much, much different to this. The nucleus is so tiny compared to the atom. In fact, the nucleus is 10,000 times smaller than the atom. 10,000 times. And in the other video, we looked at the scale of that. It was like having a penny on the centre spot of Wembley Stadium. And then you walk all the way to the edge of the stadium, and that's where the electrons are. So that is a huge gap, a massive gap. And that atom, you might think is the size of a stadium, but really the nucleus is the penny in the middle. All the mass is concentrated in that tiny little bit in the nucleus. And then there's a huge gap. Now, it doesn't look like it in this diagram because it would be hard to see otherwise, so we made it bigger so you can see, but really that gap is huge. Okay, I'd like you to pause the video, try and write down the answers to the following questions, and I'll put the answers up on the next slide. Okay, so if you got the answer right, give it a tick. If not, you can write in the correct answer. Okay, pens down for the next task. What I'd like to do now is, without looking at your previous notes, I'd like to draw a timeline in your books or on a piece of paper that shows the history of the atom. Think carefully about the order. If you can't think of anything, do not worry. We'll put those in later, but whatever you can in order, do that first, and then we'll put up some clues and then some answers at the end. Put in as much detail as you can remember. On the screen now is some models in order. You can use this to have a look at your answer and then add in as many more details as you can. So the more details you can remember is good. There's a few more details on the screen, but for now, the most important part is you remember the order of these models. That's the end of today's lesson. If you got stuck at any point, you can pause the video or rewind and go and have another look.